Thank you. All right, guys. So we discussed end behavior, and that's going to apply to certain parts of limits today. Estimating limits of a function at a certain point are on the final. Eventually, I think not really till tomorrow, I can't remember, we're going to talk about estimates of limits at infinity. And that's a good start for calc, but I didn't put a question on that on the final. All right, this is a fancy definition, so try to hang with me for a minute here. It says calculus centers around two fundamental problems: finding the equation of a line tangent to the graph of a function at a point. Okay, when you have a function, a line that will touch at only one point, the equation of this line is going to be important next year. So the very first unit we did, finding the equation of a line through a point, back in August, is going to be important. Finding the area between the graph of a function and the x-axis. So if this was the x-axis and you wanted to know what the area was underneath this curve, that's something you will learn next year as well. All right, fundamental to the solution of these problems is an understanding of a concept called a limit. It says, we talked about this in 1.3, but we didn't really. We skipped it back in 1.3. We talked a little bit about it, but we didn't use the word limit. If a function approaches a unique value as it approaches from either side, okay, then the limit exists and it would be that unique value. For example, looking at this line, even though there's an open circle right here, okay, the limit exists at C, the x value, and the limit is L, the y value, because this function is approaching that same y value from both sides. It doesn't matter that it's undefined at that point, as long as it's approaching the same y value from the left and the right, the limit exists there. All right, so this is a really quick example because this is a line, crosses at 1 on the y, has a slope of -3, it says find the limit at 2. Well, this is a continuous function, right? There's no holes, doesn't say. So basically what's happening at 2 is what you would get if you substituted it in. So if you put a 2 in there, whoops, that's a 3, that's a 2, you'd get -5. The other way we're going to check this kind of thing is that it has to approach that same value of -5 from both sides. Okay, so if we had put into our calculator 1.9, 1.99, 1.999, you see it's getting closer and closer to -5. If you come from above, 2 and 1/10, 2 and 1/100th, 2 and 1/1000th, it's also getting closer and closer to -5. So therefore the limit exists and it is -5. It's really easy, right? There are going to be some times when you can't do that. For example, this, if I put a 3 in here, I'll get over 0, right? And that means it's undefined. So we have to figure out what this is approaching at that point, and even though it's undefined there. Actually, if we factor the top, does anybody remember what happened when we had a common factor top and bottom? They do, but what does it mean about the graph? There's a hole, right? There's a hole. And how did we find out where that hole was? We canceled those and then we put the 3 back in. So even though we've canceled this out, it wants the limit at 3, so we put the 3 back in and we get 6. If we graphed this, we typed this in, x squared minus 9 divided by x minus 3, and we put in values as we get closer and closer to 3 from below. it gets close to 6. As we get closer and closer to 3 from above, it gets closer to 6. So there is a limit at 6, even though there's a hole there, because both sides are approaching the same y value. All right, so when I say we're going to try some values and get closer and closer from above and below, we're going to put our calculator in Ask Auto mode. So that is, remember I said radians and functions for today. But then if you go to second window, Ask and Auto. Everybody remember this? Second window, Ask, and then Auto. Pretty good. All right. So here's a definition. Okay, it says the limit of a function as x approaches c does not depend on the value of the function at c. If the limit here is approaching L, whatever this is, the y value, at C, even though it's undefined, and that's because both branches to the left and right are approaching the same y value. That's also true here, guys. This question's on the quiz. If I tell you there's a defined point up here, and it asks for the limit at C, the answer is still going to be L, because it's approaching this and approaching from the left and the right. It's approaching this y value. Doesn't matter that it's actually up here. It says the limit does not depend on the value at C. And here, when it's defined at C, it's still L. All right, so let's, one more time. Your stuff is over here, Kayvon. Okay. It is important to understand that the limit is not about what happens at a number. Instead, a limit is about what happens near or close to that number. And just also remember that the limit is a y value, not an x value. Okay? Then we're going to talk about one-sided limits. When it looks like this and it has like 3 with a minus behind, this just means as we get closer to 3 from the left, or they will also say from below. And when we see something like this, this means we're looking, what is it approaching as we get closer to 3 from the right? And it's called a right-hand limit. It's also called from above. All right. A two-sided limit is when the left-hand limit and the right-hand limit are the same. Then you can say the limit exists at that number and it exists at whatever you got for the L of both left and right. And that's what it says at the top of your paper. It says if you approach a number from the left and you approach it the same number from the right here, then the limit exists if and only if both one-sided limits exist and are equal. Okay, now that you're just like, what is she blabbing on about? Let's try this, okay? I'm going to graph this on the calculator just so you think I'm not making this up. Do you remember where absolute value is? Anybody? So we're going to go to y equals. We need absolute value of 2x. It's under math, arrow to the right. Absolute value. Then we're going to put 2x in there. Then either close parenthesis or go out of the absolute value box, depending if you have an older calculator. And then divided by x. I'm thinking we can just do a standard window, so zoom 6, and we get this picture. The first question asks, evaluate the, what does this mean again? Anybody paying attention? What does that little 0 with the minus after it mean? Yes. So as I get closer and closer to 0 from the left, so like, okay, I'm coming from the left. What is the y value getting closer and closer to, guys? Well, the y value is staying at what? Really? The y value? Okay. As this gets closer and closer to 0, the y is staying at -2. So the left-hand limit is -2. Okay, that's what it says in this red box right here. Then it says what happens as you get closer and closer to 0 from the right. Okay, so I'm over here now. As I get closer and closer to 0 from the right, 0.7, 0.6, 0.4, 0.3, the y value is staying at +2. Okay, so the right-hand limit exists. It's at 2. Then it asks this question here. Does the overall limit at 0 exist? The answer is no, because the left and right-hand limits are not the same. They don't approach the same number from the left as it does from the right, then the limit does not exist. This question shows it's approaching, so it says it stays at 4. This is the definition of the function. It stays at 4 unless it's -3, and then it drops down to -2. So from the left, it's getting closer and closer. Well, it's staying at the y value of 1, 2, 3, 4. From the right, it's staying at the y value of 4. So even though the value of the function drops down here, we say the limit at -3 exists and is 4, because it was approaching 4 from the left and the right. Doesn't matter where it is at -3, it matters where it is close to -3. All right, this one says the left-hand limit at -2. Here's x equals -2, okay? But it doesn't say I'm at -2, it says I'm getting closer from the left. So I'm actually down here. So what is the y value down here? Can anybody see that? 1, 2, 3, -3. X approaches, oh, that's +2. I can't read. All right, let me try that again. This says it approaches +2 from the left. So if I go over here, here's +2, but I can't start at 2. I have to come at it from the left. So the y value I'm at is +2. What? That's not the left. Oh my God. Stop the video. I can't do this question. All right. This says x approaches 2 from the left. Here is x equals 2. If I'm coming at that from the left on the graph, I am on this y line, which is 1. If I am approaching +2 from the right, the function is up here at the y value of 2. Therefore, the limit does not exist at 2 because it is approaching, it's at 1 and then it's at 2, and they're two different values. We'll try another one of those maybe soon. All right, this says what happens at 4, the limit at 4. So they graphed this. This is the x value at 4. It has a vertical or asymptote where it's undefined at 4. What happens on the left of 4 is it's approaching infinity. On the right of 4, it's approaching infinity. The issue is, okay, we can conclude that the limit does not exist because it's not approaching a specific value. But we are allowed to describe the behavior by saying it approaches infinity. What we're going to, from both sides, left and right. So what we're going to write is not necessarily what you'll write in calc next year, but we're going to write does not exist, and then we're going to say it approaches infinity. You can only say that if it's doing infinity on both sides. I just don't want you to think that infinity is an answer to a limit question. It's a descriptor. It says it is important to understand that the expressions the limit approaches negative infinity or infinity are descriptions of why the limit fails to exist. The symbol infinity and negative infinity do not represent real numbers, so they are not actual limits. That's why I'm going to have you write does not exist and infinity. Okay? This one, real quick, As you get closer and closer to 0 from the left, it's going down, so it's approaching negative infinity. As you get close to 0 from the right, it's approaching positive infinity. So therefore, it's not approaching the same number. See, these are really negative numbers and these are really positive numbers. So you just have to say the limit does not exist. Are we going to get to some? Oh, this is the other possibility, okay? A limit also does not exist if it oscillates above and below, okay? So if you asked about the limit at 0 and it's doing something crazy like this, you have to say the limit does not exist. If you put this value in, x squared sine x, I put it in and I graphed it. It does show that it exists at 0. It's closer and closer to 0, so the limit would just be 0. All right, reasons a limit does not exist. Reason 1, if it approached a different value from the left than from the right, you'd have to say it does not exist. If it increases or decreases without bound to the left or right, in other words, it's approaching infinity or negative infinity, then yeah, I shouldn't make that look like a... Then you have to say it does not exist. And the third reason would be if it oscillates between two fixed values. That's where it just goes back and forth real fast. Not going to see that probably. All right, so here's the first question we have. If we graph this, it's the same one we just did, but with a 3. So we're going to put a 3 in here and graph it. And the question asks what? Anybody tell me what this is asking? As we get close to 0 from the right. So as x approaches 0 from the right. So here what we're doing is we're coming from the right, getting close to an x value of 0. And what is the y value staying at that whole time? 3. Okay, now we're supposed to graph this one. How to get rid of that? Okay, just kidding. Go away. Nope, just kidding. I don't want to do that either. There we go. All right. What was it, guys? You guys already got absolute value of x minus 2 over the quantity x squared minus 4. So under math, arrow to the right, absolute value, was it x minus 2? And then it was divided by the quantity x squared minus 4. Make sure you put parentheses. That's the biggest issue for most students, is typing these in correctly. All right. I'm just going to leave this window. Oh, it worked. What do you know? And then it asked which direction. This says getting closer to negative 2 from the left, right? Okay. What are some numbers that get close to negative 2 from the left? Okay. So you could type in negative 3, negative 2.5, negative 2.1, negative 2.01. Those are getting closer and closer to negative 2, yes? Okay. Just so we're clear on what that means. So if I trace to negative 3, like Kelsey said, and then I go closer and closer to negative 2, what's happening to the y value? Yes. So the left-hand limit, you could say does not exist, but it is approaching infinity. Now, if it asks for the plain old limit at negative 2, you would say it does not exist at all because the left is going up and the right is going down. Yes, Kelsey. What is happening to this graph as you get close to -2 from the left. This is basically saying it's just going up forever, okay? But it does not have a limit, because a limit means a specific value it's getting close to, and this one doesn't. We found what's called the right-hand limit, because it was approaching from the right, okay? If we had found the left-hand limit here, it would have been approaching negative, it would have been staying at -3. So this doesn't actually have a limit at 0 proper. In other words, if they didn't put that little plus sign there, we would say does not exist. Because from the left and from the right, it's approaching 2 different y values. But as long as they only asked for the left-hand limit, it does exist. I know, it's kind of confusing. We'll keep going here. All right, this is a graph that actually, if we factored this would divide out. It does have a hole, but practice typing this, guys, because you have to put parentheses around the top. Someone read it to me. X squared. Thank you. You need parentheses around the top and around the bottom. Just going to leave my standard window and see what happens. Okay, looks like it's aligned, so we shouldn't have any problems, but it says, what is the limit at 2? Well, if I try trace 2, what happens? What's the y value? Nothing. There's actually a hole here, okay? Does that mean there can't be a limit? No. We have to see what's happening very close to there. So you could go ahead and type numbers here, or you could go to the table. If we go to the table, I have some numbers in here. I don't know if I can delete those or not. Don't look like it. We won't worry about them. What are numbers close to 2 but below 2? That's what we're supposed to be doing, right? 2. Okay. 1.9. 1.999. Okay. What are numbers just above 2? 2.1. Is there something even closer? 2.01. Okay. The limit exists if it's approaching the same value from above as it is from below. What's it getting closer and closer to from both ways? 7. Okay. We're going to eventually learn. We could have factored this. It had a hole there, but once we got rid of the hole, we could have put the 2 in there and said it was going to be 7. But you can do it either way on the quiz, okay? This one, the top doesn't factor. It says x squared plus 27 over x squared minus 9. Over what is it, guys? They're both squared? Oops. Oh my goodness. Do I have it right now? X squared plus 27 over x squared minus 9. All right, so it looks like this. The first one asks what's happening. Oh, it asks if there's a limit at 3. Okay. Doesn't say from the left or from the right. So if I look at 3, if I type trace 3, I get undefined. If you kind of look at what's happening here at 3, does it look like it's doing the same thing to the left as it is to the right? No. We could go to the table, and what's just below 3? And even closer would be 2.99, right? If we put in just above 3, we'd have like 3.01, something like that. 3.001. Why does this not work? They're all 6s, but they're not the same number, right? Well, I have a negative 600 or a positive 600 in my bank account makes a big difference. As long as they're not the same number, then it has no limit. And we can't say anything about it. We just say does not exist. All right, number 5 looks like this. Can I just assume you could type that and we can just talk about the picture here? At negative 2 is here. Okay? What do we say when it looks like this on either side of negative 2? Yes, it doesn't really exist. It doesn't approach a particular number, but we can say on both sides it is going up infinitely. We say increases without bound in calculus. All right, this one, if you were to type all that in, guys, you'd need parentheses around the top and the bottom. This is what the graph looks like. Looks like a line, but when I put in a 4, can you see down there? I put in a 4 and it got undefined. So then I went to the table and I put in just below 4 and just above 4. And what are they both? Pretty close to 8, okay? And again, if I had factored this and then divided that factor out and then put the 4 in, I would have got 8. So this one has a limit at 8. How we doing? Kind of starting to get this? All right, number 7. What is this asking though? Oh, let's type this one in because 7a and b both refer to the same graph, okay? So it's x plus 7, right? Is on the top or not? Divided by the quantity. Thank you so much. Okay. So standard graph is this, standard window. And then it asked, what's the first one asked, guys? -1 from the left. So if I'm thinking about a number line, from the left, I would have like -2 over here, right? -1.5, -1.01. Those would all be to the left. Okay. So if I go to the graph and I just trace, at -1, it's undefined. But if I go off to the left a little bit, what's happening? Okay, here's -2. It's at -1. As I get closer, like -1.5, it's at -2. What's even closer to -1? -1.1, down at -10. -1.001, that's really close to -1, right? And it's clear down at -1000. So what is it doing on that left-hand side? If they only ask about the left-hand side, it's going towards -infinity. What is it doing as you approach -1 from the right? What are some numbers on a number line that are above -1? Well, the next one would be 0, but what's closer to -1? -0.9, -0.99, yes? So if I go to the graph or the table, it doesn't matter, and I put in -0.9, I'm at 10, -0.99, getting closer and closer to -1, I'm at 100, so what's it doing? As you get closer from this way to -1, it's going up, so it's approaching infinity. If they just ask this, the limit as x approaches -1 with no left or right on it, you would just say does not exist. Can't even describe it because one side's going up and one side's going down. All right. Then it talks about what happens. This is really end behavior. Okay? Everybody awake? About 10 more minutes here, guys. It says, as the limit approach, if a value approaches a number, as x increases, then it is read the limit approaches infinity as you go off to the right. So this is asking, we have done this. As x goes to infinity is just asking what's happening to the right end of the graph, right? Go off to the right forever. End behavior. We did end behavior forever and people still struggled with it. This x approaches negative infinity means on the far left, what's happening? Okay? And they use this notation. Vertical asymptote, okay? If there's a vertical asymptote in the graph, on either side of it, the graph will either go up or down. If there's a horizontal asymptote, though, what happens? Do you remember? It means the graph stays close to that value, right? Okay. This is asking, this notation right here, as x approaches infinity, means what's happening on the far right of this graph. On the far right of this graph, as I get really, really big x values, what's happening to the y value? It's getting closer and closer to 0. So you would say approaches 0. All right, this graph, it's asking what happens, which end, which side? Negative infinity means far left, yes. So they put in really negative numbers, and what is it getting closer and closer to? 2. All right, the limit in example 6a, this one, okay, indicates that there is an asymptote at y equals 0. Well, the limit in 6b, this one, indicates there's a horizontal asymptote at y equals 2. All right, this would have does not exist. Do you see what the graph's doing, guys? It's going up and down, up and down. Even the plain old sine graph, if I graph y equals sine of x, is it approaching a particular value off on the far right? No, it doesn't have a limit because it just goes up and down between -1 and 1. All right. This is an example that's on your notes. It asks this. Can you see that little tiny thing from your notes? It says, as we go to the right, as we go off to the right, what is this getting closer and closer to? They put in really big numbers, and this is approaching 0. All right, so let's try these. Number 8, I graphed this, and I put in some really big numbers, 9, 99, 999, 9999. What is it getting closer and closer to? And why did I pick those numbers? Because this was positive infinity, right? So the far right. This one I should be putting in what kind of numbers? Really negative numbers, okay? Now if you typed this in, you would need parentheses top and bottom. I put in -9, -99. You realize -100 is just really close to -99. I'm just lazy and I've just put in 9s, okay? You could put in -1,000,000, doesn't matter. I put -99999 just because I like to type a bunch of 9s. But what's it getting closer and closer to? -3. This is just end behavior, okay? What happens though here? We can envision this graph, right? You have to be in radians, and I did a zoom trig, I believe. But this is what the graph looks like. As I go off to the right, is it getting closer and closer to anything? No, if you notice, I have a 1, a -1, a 1, and almost a 0. It's just going up and down. This one I graphed with the top and the bottom. I put in 9, 999, 999. Can anybody tell what that's getting closer and closer to? Okay, it's 6.7, but it's 1, 2, 3, 4, 5 places over, and the next time it's 6 places over. So it doesn't matter that it's 6.7, it's just getting closer and closer to what? 0. Yes, I'm sorry. Thanks for reminding me, especially since video. Yep, does not exist. Great question. All right. What is this asking? Tell me what this is asking. Type this in, Hofbauer, and then do what? Yeah, go really far to the left, like -9, -99, -9999, right? Okay. So I did that. Can anybody see those? What is happening to these y values? Look at the graph. It's just getting what? More and more and more negative. So if anything, we would say it approaches what? Yes, but it really doesn't have a limit then. It doesn't have an end behavior other than that it's approaching negative infinity. All right, number 13. Let's try this one because we haven't done a trig one and we got a couple minutes here. Make sure you're in radians. How would I type that? Anybody know where I need parentheses?
Right.
When I type sine, it brings up a parenthesis. I can put 2x in there and then close that parenthesis. Okay, that's the whole function for the top. And then I'm supposed to just divide by x. I really don't need another parenthesis. Everybody got it? I'm going to do a zoom trig maybe. Okay. It wants to know the limit at 0. So how, whoops, sorry, trace 0. It's undefined at 0. In order for there to be a limit, it has to be doing what? The same thing coming at 0 from the left as it is from the right. So if I go to -1 and I get closer and closer to 0, what is the y value getting closer and closer to? 2. If I go over here a ways and then I come back at it from the, that would be from the right. Did I just say right a minute ago? That was from the left. But again, the y value is getting closer and closer to what? To 2. So what is the limit? 2. Because it was approaching 2 from both above and below, the limit is 2, or the left and the right. All right, application question. We still have 5 minutes, guys. We're supposed to type this in. I'll just show you here. I did type it in, okay? It says graph it for 0 to 20, and this is what the graph looked like. I don't know if I can tell where it started. Looks like it's somewhere, I don't know what my window was here. Anyway, it flattens out at about 4, because here's the y values. I'm just going to do something like this, okay? It says, I lost my cursor. Use the graph to estimate the number of grams present after 8 hours. So I typed in an 8 right here. Whoa, I don't know what just happened. I typed in an 8 and it said 3.74 roughly. Okay. And then it says, what is the limit? What is this going to reach for bacteria growth as you go off to infinity? So I put 9, 999, 9999, and what did it approach? Can anybody see? Yep, it got stuck at 4 and didn't go above. Again, this was bacteria growing in a dish, so it's showing that things do approach limits where it can't go above. All right, this is a value of a car. Here's the graph. It would start really high, and then it comes down and goes like this, okay? I typed it in. I set the window. Notice the window needed to be high because the value of the car started at 30,000. Okay. Then it says use the graph to estimate the value of the car after 10 years. So I put that 10 in and I got $847.43. Then it says estimate the value as you go off to the right. This is exponential decay. What is the car going to be worth eventually? Yeah, nothing. If you look, 1 times 10 to the negative 11th or 0. Okay. Eventually worth nothing. All right, so those are just a couple applications. The homework is just those problems down at the bottom of the page there, okay? Let's see, what time is class done? 12. Okay, let's see if we can just do these 4 questions since they're done on the page. There's a picture, right? This says, what does this mean? The limit at -6. Not from the left, right? At -6. So when x is -6, what y value does this graph appear to be at? That's it. Number 30 says the limit at 4. That means when x equals 4, what y value does the graph appear to be approaching? Yes, it's not the fact that there's a dot up here. This graph for g of x now, what is the limit at 4? So when x equals 4, what's happening? But, yes, but both sides it's going towards infinity. Then it asks what's happening at -6. When x is -6, what's happening? One side is up and one side is down, so we just say does not exist. Is that a good conclusion? Little piece to do those 4 together, and hopefully you got that. All right. Remember when it says infinity, it's talking about end behavior. All right, so your homework is just to finish those few little questions, literally 10 minutes.